Hello, my students of third prep. Today we are going to start a very important lesson which talks about the relation between chords of a circle and the distance from the center to these chords. Let us start by explanation first. What about the relation between chords of a circle and its center? First of all, when you look carefully to such a circle, center M, and you have AB, a chord of this circle, try to look what about the distance from the center M to the chord AB, the perpendicular distance, of course. First of all, AB is a short chord, so the distance MX is big. When AC becomes longer, so the perpendicular distance MY becomes smaller. Try to make AD a longer chord, so the perpendicular distance MZ is shorter. This means that the closer the chord is from the center of the circle, the longer its length. It means when the chord is short, the distance is big. The chord becomes longer, the distance becomes shorter, and so on. Now try to put greater, smaller, or equal in the following statements. If you have a figure, circle center M, AB and CD are two chords, MY 3 centimeters, MX 5 centimeters. Here the perpendicular distance MX is longer than MY. So it means that what's the relation between AB and CD? Of course, yes, AB will be shorter than CD, so it is smaller than CD. Then, if you have a figure like that, you have circle center M, DC 7 centimeters, AB 10 centimeters. Yes, the longer chord than the shorter distance. So what's the relation between MX and MY? That's correct. You are going to notice that MX is smaller than MY. Then finally, what about circle center M, DC 8 centimeters, AB is 8 centimeters. Two chords are equal. So what about the relation between MX and MY? Yes, they will be equal in length. So MX will be equal MY. Now you are going to have a very important theorem. What about this theorem? This theorem says that if chords of a circle are equal in length, then they are equidistant from its center. If you have a circle having two chords, AB and CD, these two chords are equal, then the perpendicular distances must be equal too. So the given is AB equals CD, MX perpendicular on AB and MY perpendicular on CD. What about the required to prove? I want you to prove that MX equals MY. Then we are going to make a construction. What about the construction? We are going to join MA and MC. Now let us try to prove such a problem. First of all, you have MX perpendicular on AB. It means that AX equals XB. Then AX equals half AB. By the same way, MY is perpendicular on CD. Therefore, CY equals YD. And in this case, we can say that CY equals half CD. As AB equals CD, so half AB equals half CD. Here we can say that AX equals CY. Then we are going to make congruency in the two triangles AXM and CYM. Try to find three conditions. The first one is AX equals CY. The second, MA equals MC equals radius. And finally, the third will be measure angle MXA equals measure angle MYC equals 90 degrees. Then the two triangles are congruent. And here we can say that MX equals MY. Now we are going to have an important corollary which says that in congruent circles, chords which are equal in length are equidistant from its centers. This means that M and N are two congruent circles, AB equals CD, MX perpendicular on AB, NY perpendicular on CD. Therefore, MX equals NY. Now let us have some examples. In the figure opposite, if AB equals CD, try to prove that XE equals YO. First of all, since AB equals CD and MX perpendicular on AB, MY perpendicular on CD, therefore, that's correct, MX equals MY. And as AB equals CD, then by subtracting, you are going to notice that ME minus MX equals MO minus MY. Therefore, OY equals XE. Another example. In the figure opposite, try to find measure angle MXY. First of all, what about MX? It is perpendicular on AB. What about MY? It is perpendicular on CD. As AB equals CD, so we can say that MX equals MY. Then in triangle MXY, you have two equal sides. So there are two equal angles, which are measure angle MXY equals measure angle MYX, which is equal to 180 minus 100 divided by 2 as they are equal in measure to obtain a result as 40 degrees. Another example. In the figure opposite, AB equals CD, try to find the length of AB. First of all, you have two equal chords. Yes, as AB equals CD, you are going to notice that ME perpendicular on AB and MO perpendicular on CD. So therefore, X plus 2 equals 6. And in this case, we can find the value of X as 4. So to find the length of CD, it is 3X plus 4. So it is 3 multiplied 4 plus 4, which is equal to 16 centimeters. And as AB equals CD, so we can say that AB also equals 16 centimeters. Another example. In the opposite figure, you have measure angle B equals measure angle C, AX equals XB, and MY perpendicular on AC. Prove that MX equals MY. First of all, since measure angle B equals measure angle C, therefore, yes, it is an isosceles triangle. So AB equals AC. Since MY is perpendicular on AC, therefore AX equals XB. And since MX is perpendicular on AB, therefore, that's correct, MX equals MY. What about the converse of this theorem? You know that the theorem says that chords which are equal in length is equidistant from the center. The converse says in the same circle or in congruent circles, chords which are equidistant from the center are equal in length. The converse of the theorem. The chords which are equidistant from the center will be equal in length. Then let us have some examples. In the opposite figure, that's correct, you have MX equals MY, YD equals 7 centimeters, and I want you to find the length of AB. First of all, as MX perpendicular on AB and MY perpendicular on CD, and as MX equals MY, so you have perpendicular distances equal. Then we can say that AB equals CD. Two chords will be equal in length. Then CD will be 7 plus 7 equals 14 centimeters. Another example. In the figure opposite, MD equals ME. Measure angle B equals 65 degrees. AD equals DB. Try to find measure angle A. First of all, when you look carefully to the figure, you are going to notice that AD equals DB. So MD is perpendicular on AB. What about ME? It is perpendicular on AC. So MD equals ME. That's correct. Therefore, AB equals AC. Perpendicular distances are equal, so the length of the chords are equal. So in triangle ABC, you are going to notice that you have two sides equal. AB equals AC. So measure angle B will be equal to measure angle C, which is equal to 65 degrees. Can you find measure angle A? Of course, it is a triangle. ABC is a triangle. So measure angle A equals 180 minus 65 plus 65 to obtain a result as 50 degrees. Another example. In the figure opposite, X is midpoint of BC, and Y perpendicular on EF, MX equals MD, and Y equals ND. Try to prove that BC equals EF. At the very beginning, you are going to notice that AB is a common chord, and NM is the line of centers. So we can say that NM is perpendicular on AB. And since MD equals MX, that's correct. And since BX equals XC, therefore MX is perpendicular on BC. And here you are going to notice that that's correct. AB equals BC. And this is going to be number 1. Then, since ND equals NY, that's correct, ND perpendicular on AB, therefore NY perpendicular on EF, therefore AB equals EF. And this is going to be number 2. From 1 and 2, you are going to notice that BC equals EF. Another example. In the figure opposite, MX perpendicular on AB, MY perpendicular on CD. EY equals XD. Prove that AB equals AC and AD equals AE. At the very beginning, when you look carefully to the problem, you are going to notice that MX is perpendicular on AB and NY is perpendicular on AC. MD equals ME equals radius and XD equals EY. Therefore, AB equals AC. And this means that half AB equals half AC. So AX equal AY. Then you have AX equals AY. Try to make congruency between the two triangles. So in triangle AXD and AYC, you have three conditions, which are AX equals AY, EY equals XD, measure angle AYE equal measure angle AXD equals 90 degrees. Therefore, the two triangles will be congruent. And from congruency, you are going to notice that AD equals AE. Another example. What about central angles and measuring arcs? It is a new lesson. What about central angles and measuring arcs? Look carefully to such a figure. You have AB arc, and it is called AB minor arc. It means the small arc. If you plot a point C, so ACB is called ACB major arc, as it is greater than half the circle. So when the arc is less than half the circle, it is called minor arc. When it is greater than half the circle, it is called major arc. So ACB is called major arc. What about angle AMB? Angle AMB is called central angle. It means it is an angle whose vertex is lying on the center of the circle, and it is subtending an arc AB, which is the minor arc. What about angle AMB reflex? AMB reflex is called central angle subtending an arc ACB, which is the major arc. So central angle is an angle whose vertex is the center of the circle and the two sides are radii of the circle. Then what about the measure of the arc? The measure of the arc, it is the measure of the central angle opposite to it. So to measure the arc, you can measure the central angle subtending it. Then let us have an example. In the figure opposite, you are going to notice that measure AD arc equals the measure of the central angle subtending to it. So measure AD arc will be 60 degrees, which is equal to measure angle AMD equals 60 degrees. So what about measure CB arc? Yes, measure CB arc equals the measure of the angle subtending to it. So it is equal to measure angle, that's correct, CMB, and it is going to be equal 90 degrees. What about measure DC arc? Yes, DC arc is exactly the same as measure angle, that's correct, measure angle DMC, which is equal to 30 degrees. Why? Because angle DMC, its measure equal 180 minus 90 plus 60 to obtain a result as 30. So measure angle DMC equals 30. So measure DC arc equals 30. What about measure AB arc? AB arc equals the measure of the central angle subtended to it. So it is equal to measure angle AMB, which is equal to 180 degrees. Another example. In the figure opposite, AB is the diameter of circle center M. Find the value of X. Then find measure AC arc, measure AD arc, measure BC arc, measure CAD arc, measure CBD arc. First of all, since AB is a diameter, therefore measure angle AMB equals 180 degrees. And here we can say that 4x plus 3x plus 5 equals 180 degrees. So it is 7x plus 5 equals 180 degrees. Then 7x equals 180 minus 5 equals 175 degrees. To find the value of x, so x will be 175 divided 7 to obtain a result as 25 degrees. This is the value of x. What about measure AC arc? Measure AC arc equals the measure of the central angle to x. So it is 2 times 25 equals 50 degrees. What about measure AD arc? Measure AD arc equals the measure of the central angle, which is 4x. So it is equal 4 times 25 equals 100 degrees. What about measure BC arc? Yes, measure BC arc equals, that's correct, 180 minus 50 equals 130 degrees. What about measure CAD arc? It is 50 plus 100 equals 150 degrees. Finally, what about measure CBD arc? It is 360 minus 150 to obtain a result as 210 degrees. Another example. By the end of this example, we reached the end of our lesson. I wish that all of you understood it. Thank you and goodbye.